We're on the home stretch with graphics assets. This time we'll pull out the custom fonts that we see overlaid on the settings screens and in the dialogue sequences. Now, dealing with fonts can be complicated, but we'll defer that discussion until we actually use them in the prototype. For now, we'll stick to the formula by using a Hex Editor to estimate the dimensions of the character glyphs and create a C utility to transform them into bitmaps. First, we'll make the font workspace and copy the 3 suspected font archives, the tdlet.cin, td.ltr, and td.lt2. We use the same renaming convention from the last few files. I may as well grab the default palette in the old make file just in case. Now we'll start with the CN file in the Hex Editor. Now, although these are fonts, they're actually regular pre-rendered graphics and not in a vector format normally handled by the OS. So since they're graphics, I'm looking for the usual signs of size and presence of a palette. I'm pretty sure that they're all going to be different since we see different font sizes in the game itself. Alright, no signs of a palette. At the initial 16 width, we see some signs of perfect alignment, specifically the left and middle columns. This is a good indicator that we're either correctly aligned already or at some multiple of the actual width. Now, since most glyphs don't have any discontiguous regions, let's cut the space in half and see if we're still in line. Okay, at 8 width, there's something there. It's difficult to see to the untrained eye, but there are letters here. Let's measure the height. Now it also looks like 8, so I'd say that this first file is a nice square 8x8 strip. Let's move to the LTR file and hope we get lucky again. It's a little sparse, so let's change the encoding to DOS. Well, this file isn't as neatly aligned as the last. That probably rules out widths of 8, 16, or 24. There's some repeating here, so let's see the width. Looks like a hex width of C, which is 12. Okay, at 12 there's some clear alignment. These don't appear to be square widths though. Let's count a character off. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Alright, let's go with a 12 by 16 size for the LTR files. Now to the LT2 file. Okay, this looks messy. Let's check the width of this line. It says 19, which is 25 in decimal. Alright, 25 doesn't help, but let's try a smaller number that divides into 25. The only obvious one is 5. Alright, this looks like something. Let's count the height. 1, 2, 3, 4, 5. Alright, we'll go with a square 5 by 5. Now that we know about these fonts, let's begin programming. Now, all these files have multiple images, so we'll be outputting a horizontal sprite strip just like we did with the BLK files. The only complication is that our 3 input files have both different frame sizes and different aspect ratios. All this means is that we'll need to plug specific widths and height variables depending on the input file. We'll use the BLK file format as an example. In Notepad++, we'll edit the replacement makefile, open a source file, and the BLK source we'll use as a reference. Copy everything down to the prototype. Our program outline goes like this. We'll open the file passed in on the command line as well as the default palette. We'll have to manually set the image dimensions that we discovered earlier with the Hex Editor. Then we'll find the file size so we can estimate the number of images in that file based on known dimensions. Then we'll make the output surface with appropriate size and pointer to the color pixels. Let's get the palette from the palette file and close it. So we have to go through each image in the file. Then for each image, we have to pull out the image data, match it to the palette, and write to the surface. As usual, change the output file name, then save the bitmap. Now on to the details. Open the files the same as they are with the BLK files. We'll set the image dimensions with an if-else ladder. As with all utilities we've made, this procedure assumes correct input and would break for any other case. So the number of images is the same as it was in the BLK files. It's based on the file size and calculated dimensions. Actually, everything else here is the same, even the inner loop conditions. So let's just grab everything. Now it's obvious after making these half-dozen utilities that we keep repeating a lot of code. It would be an easy project just to make one comprehensive program that would take apart all the asset files and output appropriate bitmaps. The reason I'm not doing it is for both instructional purpose and because we're only going to use each of them a single time. With a single-use utility, we really don't need to think hard about code reuse. Now, if you wanted to consider reuse, the quickest solution would be to make a utility that takes both the width and the height of an image as command line arguments, and then that single utility will be able to convert a large majority of the assets that we've seen, as long as you already know the dimensions. Let's compile and test it out. Looks like it worked out. We now have 3 font sources that we'll use during prototyping. One of these files appears to have a lot of blank space, but we'll take care of that down the road. So over the last half-dozen videos, we've turned many of the traffic department graphics assets into standard bitmaps that are portable to game engines and libraries. Now we've finished with graphics for now, but we have more assets to consider, such as sounds and game maps. After that, we'll kick off the prototype.